Your location or position can be described in the largest of terms, as in the Milky Way galaxy, or in the smallest of terms, 3 feet north of the southeast corner of the MS1 room at Hammond School facing east. The things used to describe your location, the collection of objects, directions, and distances, is a frame of reference. Your location determines your point of view, the spot at which you are seeing or viewing something. Your point of view also affects your line of sight, what you can view of something from your point of view. Line of sight was how sailors learned early on that Earth is round. If the Earth were flat, sailors would be able to see other ships or land get smaller and smaller until they, the sailors, reached the edge of the Earth and fell off. When something fell off the edge of the Earth, it would tip over and fall. As you can see in this first diagram, your line of sight would extend in a straight line, allowing you unlimited views of the ship as it moved away from you or as you moved away from it. This is why it would appear to get smaller and smaller. Instead, sailors saw ships or land get smaller and smaller and then appear to sink into the ocean when it reached the horizon, the place where the sky and ground appear to meet. Things appear to sink because they are traveling below the line of sight of the observer. As more of the ship or land leaves the line of sight, it appears to sink into the ocean more and more. As you can see in this second diagram, the line of sight of the observer does not travel in a straight line. It travels at an angle because the observer is in fact standing on a curved surface. Our sight cannot travel around a curve, therefore it must only travel in a straight, angled line from our point of view. These observations help us reach the conclusion that Earth is in fact a round planet. It rotates or spins on its axis once every 24 hours. Earth is tilted on its axis 23.5 degrees. It is tilted so that the axis points to Polaris, the North Star, at all times. Notice in this diagram that the axis of the Earth is always pointed at the same thing, no matter where it is in its revolution around the Sun. Earth revolves or orbits around the Sun once every 365.25 days. The orbit of Earth is very close to a circular shape. It is much closer to a circular shape than to the oval shape that is sometimes used to represent Earth's orbit. This means that the Earth is never really much closer to the Sun at any one time. Seasons must be caused by something else. As the Earth travels around the Sun, it continues to point toward Polaris, the North Star. This causes the tilt of the Earth to sometimes be tilted toward the Sun and sometimes be tilted away from the Sun. In this diagram, you can see here that this section of Earth is currently tilted towards the Sun, whereas here, this section is tilted away from the Sun. The part of Earth tilted toward the Sun is experiencing summer, while the part of Earth tilted away from the Sun is experiencing winter. The Sun's rays, or light, can travel only in a straight line. Due to Earth's tilt, not all of the Sun's rays hit Earth the same way. Some rays hit the Earth directly, or straight on. These rays do not have to travel through as much of Earth's atmosphere as other rays. These rays are able to provide more energy than indirect rays. Indirect rays hit the Earth in a way that they have to travel through more atmosphere and their light is spread over a large area. In this second diagram, you can see the area that the light has to spread out over is much greater with the indirect rays than the area the light has to spread out with the direct rays. Traveling through more of the atmosphere diminishes the power of the Sun's ray. Making the ray spread out over a large area causes it to be even less powerful. When we are receiving more direct rays, as in when we are tilted toward the sun, we receive more powerful rays from the sun, which cause more heat. This is our summer. When we are receiving more indirect rays, as in we are tilted away from the sun, we receive less powerful rays, causing less heat. This is our winter. Spring and fall are caused by Earth transitioning from being tilted toward the sun to being tilted away from the sun. This causes a difference in how much of the sun's light we can receive in one day. The days of the year that we receive about 12 hours of daylight and 12 hours of night are called equinoxes. There is usually one day where we experience the most daylight and one day where we experience the least. These are called solstices.